We're going to examine how to find the equation of a line depending on the data that you are using to specify the line. You can specify the line by giving 2 points. You can specify the line by giving 1 point and the tiltiness of the line. Tiltiness specified by a quantity called slope. Now, how slanted is the line? Now, if you have that slant or slope and 1 point, a special point called the y-intercept, which is where the line cuts the y-axis, you've specified the line. And if you give 2 special points, the x and y-intercepts, these are the points where the line cuts the x-axis and the y-axis. In all 4 of those cases, you have specified the line. There are formulas for coming up with the equation of the line, and that's what we want to illustrate. Now, what are these equations that we can use for these 4 cases? Well, here's a table that has the 4 formulas that are of use here. If you have 2 points, this equation is called the 2-point form of the line. The given points have coordinates x1, y1 for the first point and x2, y2 for the second point. X and y are the coordinates of the generic point on the line. This quantity on the right, this fraction on the right, is the slope. x2 minus x1 is the horizontal displacement. y2 minus y1 is the vertical displacement. This is generally called the run. This is generally called the rise. So rise over run is the quantity called slope. This gives you the tiltiness of the line. If you have a single point and the tiltiness or slope of the line, you can use either of these 2 formulas. M is the letter often given to the slope. So this m is actually this fraction here. x1, y1 are the coordinates of the point that you have. If you bring the y1 to the right, then the equation can be put into form y equals m times x minus x1 plus y1. The slope-intercept form is y equals mx plus b. M is the slope. B is the y-coordinate, the point where the line crosses the y-axis. That's called the y-intercept. And if you have the 2 intercepts, the x-intercept and the y-intercept, you actually have 2 points. A is the x-coordinate, the point where the line crosses the x-axis. B is the y-coordinate of the point where the line crosses the y-axis. Intercept form, special case of the 2-point form. General form, sometimes called the normal form, sometimes called the standard form. Sometimes the C is on the left. Some books will put the C on the right. This is not a form that you would use to obtain the equation of a line, but it's often a form in which the equation of the line will be presented. Here's an example of a line determined by 2 points. The 2 points have coordinates 1, 2 and 5, negative 2. We can bring into Maple a useful package, the pre-calculus package, where there are tools for doing these kinds of calculations. So we'll make use of this 2-point form, but before we do that, let's enter the 2 points using these square brackets and 5, negative 2. Hit the enter key, and we have this sequence of points. We click on it, and in the pop-up menu that results, we have access to things about the line, and we're going to begin with a graph. So here's a graph of the line. We can improve on this graph by applying a set of grid lines, and we can change the color of the grid lines to make them different from the color of the axes. And I think I'll change the color of the line itself. And finally, I think I'll change the size of the window in which we are working. So we'll make the following changes. Let's go from -5 to 10, and in the vertical direction, -7 to 8. So here in this graph, you can see the 2 points indicated by these little circles. Coordinates of the first point, 1, 2. The coordinates of the second point, 5, -2. Now, what is the equation of this line? Well, let's reference the pair of points by its equation label. Bring up this labeling tool, put the number 1 in here, and hit the enter key. We begin the sequence of 2 points. Click on it and go to line, and this time ask for the equation. And now we have the equation y equals minus x plus 3, or 3 minus x. From this equation, you can see that the slope is -1. What does that mean? You start at the first point and run 1 unit. The rise, being negative, is down 1 unit. 1 unit over, 1 unit down, 1 unit over, 1 unit down, 1 unit over, 1 unit down. That's what the tiltiness or slope is telling you about this line. The 3 is 3 here. 1, 2, 3. That's the y-coordinate of the y-intercept, the point where the line crosses the y-axis. Now, how did this equation of the line come about? What tool did we use to do that? Well, the 2-point form. Let's take this 2-point form. I'm going to copy and paste it in down here and hit the enter key. If we click on it, we can evaluate at a point, and we have this table in which we can give values to the symbols x1, x2, y1, y2. So for example, x1 is this 1. x2 is this 5. y1 is this 2. And y2 is this -2. So you have y minus 2 over x minus 1 equals the slope -1. To isolate the y and put the equation into the form y equals 3 minus x, we can isolate the expression for y, and we've got y equals 3 minus x. Alternatively, we could go back to this 2-point formula and simply edit in place x1 is 1, y1 is 2. x1 is 1, y1 is 2. x2 is 5, and y2 is -2. Hit the enter key, and you'll see this fraction has been computed. -2, -2, it's -4 divided by 4, -1. The algebra of going from this step to this form can be done stepwise. We bring up a tool called the equation manipulator. So here you have the equation. First thing we might do is multiply the equation by x minus 1. That's the denominator here. And the next thing we should do is add 2 to both sides, and we have y equals negative x plus 3. And if I return those steps, you'll see that that's the sequence of steps that it takes to get from here to here. Here's a second example. We now have a line specified by a slope and a point. So we'll make use of the point slope form. We enter the slope and the point. Hit the enter key. If we click on this, our graph is immediately available. And using the same techniques that we used earlier, we can modify this graph to look like this. The fixed point, -2, 4. And slope 3. Now this slope is a whole number. It's actually 3 divided by 1. 1, the denominator, is the run. So you go 1 unit to the right, and then you go up 3 units. 1, 2, 3. If you go 1 unit to the right and go up 3 units, 1, 2, 3, you're again on the line. Now, this graphing tool graphed a second point, the x-intercept, which is down here. Now, how would we get the equation of this line? Well, here's one way to do it. We can use the equation label for the data. It's, equation label 1. Hit the enter key, so we again have access to this sequence of point and slope and point. Right click and simply ask for the equation. And so here we have the equation, y equals 3x plus 10. Now, how did we get that? We can make use of one of these two forms of the point slope form of the line. I'll take this second one. I'm going to copy it and paste it in here. Hit the enter key. And then right click, find evaluate at a point, and change the value of m, which we know to be 3, and the coordinates of the given point x1, y1 that we know to be -2 and 4, and that's how you get y equals 3x plus 10. Alternatively, if we drag down a copy of the point slope form of the line and simply edit in place, put a 3 here, -2 here, but if you're going to do that, you have to wrap the minus sign in parentheses, and a 4 here, and hit the enter key. You'll see that this is x plus 2. 3 times x gives you this term. 3 times 2 is plus 6, plus 4 is 10. For a third example, consider the line that's determined by a slope of -2 and a y-intercept of 3. Well, that's an example of the use of the slope-intercept form. Slope -2, intercept 3. So we can put the slope and the intercept together and click on that and get a graph. So modifying this graph as we did before, the same set of tools that we did before, this figure, and in this figure you can see the slope and the y-intercept. The y-intercept is clear, 1, 2, 3, y-intercept. How about the slope? Over 1, down 2, the down because of the minus sign. Over 1, down 2. Each time you do that, you get a new point on the line. Now, how do we get the equation of this line? Well, we could do this. Equation label 1 to reference the data, or we can simply type minus 2 comma 3 again. Hit the enter key and click on that and go to the tool that says give me the equation, and you see you get y equals minus 2x plus 3. Or we can come up here and we can copy and paste the general form, y equals mx plus b. We can use evaluate at a point to change m to -2 and b to 3. Or we can take this general form, we can edit right in place. M is -2, B is 3, and we again get the equation of the line, y equals -2x plus 3. As a final example, let's see if we can get the equation of a line that's determined by the x and y intercepts. So the x-intercept is 2, the y-intercept is -3. Well, you begin with this formula, the intercept form of the line, and using evaluate at a point, we can let a be 2 and b be -3. And we have the line in what appears to be the general form. If we want this in the form y equals, we can use the equation manipulator. Well, one thing we could do is subtract a half x from both sides, or add -1/2x to both sides. The next thing we could do is multiply both sides by -3. And now the line is in the form 3/2 x, y equals 3/2 x minus 3. So giving the two intercepts is equivalent to giving 2 points. For example, 2 points A and B represent 2, 0 for the x-intercept and 0, -3 for the y-intercept. If we ask for the equation of that line through those 2 points, we get exactly the same thing that we have here, y equals -3 plus 3/2 x. And if we draw a graph, which we can improve to this view, we can see here the x-intercept. X is 2, y is 0, And here we can see the y-intercept. X is 0, y is -3. So there is the y-intercept, -3. And what about the slope? If you advance 2 units, that's the run, you would then rise 3 units, right? There's the run 2, the rise is 3. You advance 2 units, run, rise 3. You get from this point to this point. If you do that again, 2 units, 3 units, you get to another point on the line, and each point on the line can be obtained by that same technique of run, rise, run, rise.